In this next section, we're going to learn all about prime and composite numbers. So let's do some definitions first. A prime number is a whole number. It has to be greater than 1, though. A whole number greater than 1 that has exactly 2 distinct whole number divisors. Exactly 2 distinct whole number divisors. It's usually 1 and itself. Those are usually the 2 numbers that will divide into the prime number, just 1 and itself. A composite number is a whole number greater than 1 that has more than 2 distinct whole number divisors. So if you've got more than 2 divisors, it's a composite number. So we're going to go through a couple examples here. We're going to decide if we think they're prime or composite. So what I'm going to list underneath is I'm going to list the divisors. And that's going to be for each of these. So 3, let's think about what are the numbers that divide into 3. Well, 1 and 3. There's no other numbers that will divide into 3. And since we have exactly 2 divisors, and this is bigger than 1, this one is prime. So the number 3 is a prime number. What are the divisors of 4? The numbers that will divide into 4. Well, 1 and 2, it's even, right? And 4. So this has more than 2 divisors. So this is composite. So 4 is a composite number. What about 8? Do we think 8 is prime or do we think it's composite? Well, all the numbers that will divide into 8, 1 will divide into it, 2, 4, 8. That's definitely more than 2. So composite. And then we have the number 1. Well, the only number that divides into 1 is 1. And so it really only has one divisor, which would be itself. And in order to be prime or composite, you do notice the definitions say you have to be greater than 1. So actually 1 is neither. It's not prime and it's not composite. That's an important one to know, that 1 doesn't count for either of these. And then the number 2, what are the numbers that divide into 2? 1 goes into 2, 2 divides into 2. There are no other numbers that divide into 2 evenly, so it only has exactly 2 distinct divisors. 2 is prime. In fact, 2 is the only even prime number that there is. All of the other prime numbers are odd. So that's how you determine prime or composite. That's one way to do it. So let's show that these following numbers are composite. So see, what they're telling us in the problem is, hey, these are all composite numbers, but explain why. Explain why each of these would be composite. So the number 1564, I think the easiest way to show this one is composite is the fact that it's even. If you look at the last digit, that's an even number. And so that means 2 divides 1564. Which means it's got more than 2 divisors, because 1 will divide into it, 1564 will divide into it, and then 2 will divide into it. So we've already got 3 divisors. So it's because it's an even number is really the main reason. That's why that number is composite. How about this one? 2781. Well, this is where your divisibility rules come into play. It's not even, but what about the sum of the digits? If we do 2 plus 7 plus 8 plus 1, that's going to be a sum of 18. Well, you know what? 3 divides 18. Also, 9 divides 18. So we just found a bunch of divisors of 2781. So that one's composite. We used divisibility rules for 3 to figure that one out. And you just have to find like one other number that divides into 2781 to show that it's composite. Now this next one is 3 times 5 times 7 plus 1. So another way you can figure out, well, let's just do the math and figure out what this is. If you take 3 times 5 times 7, you can just do it on a calculator or by hand, whatever, and you add 1, you get a total of 106. So this amount is 106. That's even. So 2 is going to divide 106, and so this is composite. So you just do the math on it and find out that it's an even number. And then the last one, 2 times 4 times 8, you can multiply them all together and get 64, or you can realize that if you're multiplying all these even numbers together, you're going to get a really big even number. And 2 divides 64. That's even. And so again, if it's an even number, it's not going to be prime, it has to be composite.